Hello guys, I am Ali Jawad and welcome to my YouTube channel. This is lesson number 3 on chapter number 23 Electromagnetic Induction from Physics 5054 series for Cambridge students. So those viewers who are new to the lesson, they are requested to go for lesson number 1 and lesson number 2 to learn about the prerequisites of electromagnetic induction. To understand the topic discussed in this video in a better way, I am providing the link of lesson 1 and lesson 2 over here in the video. In our lesson 1, we have discussed about electromagnetic induction by the Faraday law of self-inductance, and in the second video we have discussed that how AC generator utilizes Faraday law and Lenz's law to produce induced voltage. Usually the AC generator and turbines are used in power plants and they produce high voltage. If we may have a look on the energy distribution figure, so we can easily notice that the voltages produced by the power station are relatively very high, while the voltage utilized at household is relatively very low. So the voltage has to be dropped down to this value, otherwise the appliances may get damaged. And this drop down of voltage is achieved by the help of transformer. The transformer works on the basic principle of mutual induction. According to the Faraday law, it says whenever the magnetic field changes through the coil, an EMF is induced. Means we are going to change magnetic field and the voltage will be produced. Now, if we may try to do a little bit engineering with it, this AC supply is representing the power plant source because the AC generator produces alternating current. So according to the right hand rule, whenever we curl the finger in the direction of the flow of current, the thumb gives the direction of magnetic field. And since it is an alternating source as in the power plants, so the direction of current will get reversed after a while, and the direction of the magnetic field will also be reversed. So the magnetic field will be this way for one instant of time, while for the other instant it will get reversed, and it may keep changing itself. So this alternating current will produce alternating magnetic field in the first coil. Now, if we may try to apply Faraday law and try to pass this alternating magnetic field from the secondary coil, so the secondary coil will also experience this alternating magnetic field and voltage will be started to induced in it. This phenomena is known as mutual induction, means the current is changing in first coil, which is causing the magnetic field to change in the secondary coil, and the voltage is produced. Now let us have a look on the basic construction of a transformer. The transformer has an iron core on which the one side has the different number of turns of the copper coil, and it is known as primary winding or primary coil, while the other end has a secondary winding or secondary coil. It has a different number of turns as compared to primary coil. The energy from the primary coil is provided with the power plant or AC generator. That is why I have placed an alternating circuit over here just to represent that the incoming voltage from the power plant will be alternating. And according to the right hand rule, when the current will pass from the primary coil, the magnetic field will be induced. So the upper portion of the coil will become north, and while the lower portion of this will become south. Because of the influence and the production of this north pole at this end, we can observe that south pole will be induced at the other end. This is known as induced magnetism. However, the current in the primary coil is alternating, and according to the right hand rule, if the north pole was in the first position at the upper end, then upon the reversal of the current, it will come at the lower end, and the primary coil will experience the alternating magnetic field like this, because The source which is connected to the primary coil is providing alternating current. So, according to the right hand rule, the alternating current is producing alternating magnetic field. And this alternating magnetic field will also cause the magnetic field over here to get altered. Let us see how. Now notice that the direction of flow of current is producing north and south pole, and the south and north pole on the other end. While the polarity will get reversed, the direction of current may get reversed and the magnetic field will also be altered. And this alternating magnetic field will also cause the magnetic field in the secondary coil to be altered, like this. So when the primary magnetic field will get altered, the secondary field will also get altered. Now notice that the Faraday law says that whenever the magnetic field changes through coil, an EMF is induced. So the magnetic field has also started to change from the secondary coil, and EMF will be induced here, and this induced EMF will be of different value. For example, as you can see, I have mentioned 120 volts on the left hand side and 60 volts are being induced on the right hand side. So in this way, we have actually dropped down the voltage, and now this voltage from the secondary coil can be applied to the device which runs at 60 volt. So similarly, you can imagine that 25 kilovolts which was produced in the power plant can be dropped down to 230 volts. Now what is the basic principle? The basic principle is alternating current changes the magnetic field, and when the magnetic field changes in the primary coil, because of this iron core, the magnetic field in the secondary coil will also get changes. Now notice that secondary coil does not have any source, but because of this magnetic field alteration, the EMF is induced at this end. Now let us see what is the formula for transformer. The number of turns is directly proportional to the voltage. Means as we increases the number of turns in the primary coil or the secondary coil, the voltage will be higher and higher. And this is an experimental verification. So according to the mathematics rule, whenever we remove proportionality, we will get K. And we have a ratio V over N. So for primary coils, we can write voltage in primary over number of turns in primary equals to K, and for secondary coil, we can write voltage in secondary over number of turns in secondary. Now we can compare both the equations. So we will get Vp over Np is equal to Vs over Ns. Now types of transformer. Based on this formula, we can define different types of transformer. Because we are interested in secondary voltage, means voltage at output, because primary voltage is defined by the power plant. So let us rearrange this formula in terms of secondary voltage. So number of turns from the left hand side has gone and has been rearranged in such a manner. Now we can also rearrange the formula as Ns over Np. This is known as turn ratio. The turn ratio defines the type of transformer. For example, if the number of secondary coils are more and the primary coils are less, then this ratio will be a figure greater than 1. And for example, if it will be 2, then it will get multiplied by the voltage of primary, that was 120, and the secondary voltage will out to be 240. This type of transformer is producing a higher voltage than the primary voltage, and that is why it is known as the step-up transformer. However, if this ratio may decrease from 1 and if the secondary is less than the number of primary loops, then the answer would be in fractions. Let's say 1 over 2. So 1 coil in secondary and 2 coils in primary. So the number of primary coils are more. So if we may apply 120 volt at the primary end, notice that it will reduce it and we will get 60 volts in the end. So if I may go to the previous slide here, now let us try to apply the voltages. Suppose that we do not know voltage in secondary. So this will be the number of turns in secondary, this will be the number of turns in primary, and this is the voltage in primary. So voltage in primary divided by the number of turns in primary is equals to the voltage in secondary divided by the number of turns in secondary. So moving this number of turns in secondary to the next side, we will get Vp over Np multiplied by Ns is equal to voltage in secondary. Now let us substitute the value. Voltage in primary was 120, the number of turns in secondary was 1000, and the number of turns in, here we go, zeros are cancelled with the zeros, 5 ones are and 5 twos are. Now we can reduce this and we are getting 60 as the final answer, like this. So this is a step down transformer. For ideal transformer, the power input should be equal to the power output. We are assuming that there is no energy loss in terms of heat. So power is equal to voltage into current. To know how this formula has came over here, please go to the lessons on current electricity. I am providing link here in the video. So for input voltage, we can write voltage in primary and current in primary. And for secondary voltage, for secondary power, we can write voltage in secondary and current in secondary. So this formula is used to calculate the current and voltages in ideal transformer. Thank you for watching the lesson. Don't forget to subscribe our channel for the latest videos on the same topic. Thank you.